Welcome back, everyone, for another deep dive. This time we're tackling something I think you're all probably already using and loving, Flutter. It's this
Mhm.
awesome toolkit for building really beautiful apps that run smoothly on pretty much anything. But
Yeah.
have you ever stopped to wonder how it actually achieves that right? Once run anywhere magic. I mean, we've all used other cross-platform solutions,
Yeah.
and often they compromise on performance.
Right. Yeah.
Flutter doesn't seem to. And that's exactly what we're going to unpack today. The engine that makes Flutter tick.
Well, what's interesting here is that Flutter takes a completely different approach than most cross-platform frameworks.
Yeah.
Instead of interpreting code at runtime, Flutter uses ahead of time or AOT compilation.
Okay. So walk me through this AOT thing. Does that
Oh,
mean it's just translating my Dart code into something else?
It's a bit more than just translation. It's actually compiling your Dart code directly into native machine code for the target platform, whether that's Android or iOS. Think of it like this. Imagine you have a speech to deliver in two different languages. Most frameworks would be like having a real-time translator on stage with you. But Flutter's more like having meticulously prepared translations beforehand, so you can deliver the speech flawlessly in each language.
Hmm. That's a pretty good analogy. So no clunky interpreters or web views involved. It's truly running natively.
Exactly. And that's a major reason why Flutter apps can be so incredibly performant. They're running as close to the metal as possible. Then on top of that, you have the efficiency of the Dart language itself and the power of Skia or Impeller in newer versions, which is the graphics engine responsible for painting all those beautiful widgets on the screen.
Okay, so we've got this high-performance engine under the hood. But how does it actually take my code and turn it into something I can see and interact with on my phone?
You can think of it like constructing a building. You start with an architectural blueprint, then layers of materials and systems are built upon that foundation to create the final structure. Flutter's architecture works in a similar way.
Okay, I'm intrigued. Lay it on me. What are these layers?
At the very bottom, we have the Dart.ui layer. This is the bedrock, the interface that allows Flutter to talk to the underlying operating system and hardware. It handles things like drawing to the screen, handling touch input, and managing system resources.
So it's like the foundation of our building, making sure everything is stable and connected to the ground.
A perfect analogy. One level up. We have the rendering layer. This is where the visual magic happens. The widgets you define in your code get transformed into actual pixels on the screen.
So it's like the walls and windows of our building, the things we actually see and interact with.
Precisely. And what's really cool is that this layer is constantly working to make things as efficient as possible. It analyzes the widget tree, comparing the current state to the previous one, and only updates the parts that have changed.
That makes sense. No point in repainting the entire house if you've only changed the color of one door. But wait, we haven't even gotten to the part where we, the developers,
Yeah.
actually write code.
You're right. That's where the next layer comes in, the widgets layer. This is where we spend most of our time as Flutter developers, building the user interface of our apps.
Okay, remind me, what exactly is a widget in Flutter?
Think of widgets as the building blocks, the Lego bricks of your app's UI. Everything you see and interact with in a Flutter app is a widget, from simple text and buttons to complex layouts and animations. And they're all nested together to create a hierarchical structure, much like our building analogy.
So it's widgets all the way down, just like the
Right.
layers of our building.
Exactly. And at the top of our architectural masterpiece, we have the material and Cupertino layers. These provide pre-designed widgets that adhere to the design languages of Android and iOS, respectively.
So that's why Flutter apps can look and feel so native on either platform.
Precisely. These pre-styled widgets save developers a ton of time and effort, ensuring that your app feels familiar and intuitive to users on any device.
I love how this architectural analogy is coming together,
Yeah.
but I have to admit, when I first started with Flutter, I got a little tripped up by the whole concept of widgets, elements, and rendering. They seemed a bit abstract.
It's a fair point.
Uh,
Let's break it down further with a real-world scenario. Imagine we're building a simple to-do app,
yeah,
and we want to display a list of tasks on the screen.
okay. I can picture that. Each task would probably be in its own little box or container, right?
Exactly. So let's focus on one of those task containers. To bring that to life on the screen, Flutter goes through a three-step process, using widgets, elements, and the rendering layer.
Okay, walk me through it. Where do we start?
First, we have the widget itself. In this case, let's say it's a container widget. The widget is like the blueprint for our task container. It defines its properties, its size, color, the text it contains, and so on.
So it's like the architect's detailed drawing of what the task container should look like.
Perfect analogy. Now the element comes into play. The element is like a placeholder, a representative of that widget in the actual running app. It's linked to the widget and holds information about its current state and position in the widget tree.
So it's not the container itself, but it knows everything about it.
Exactly. It acts as a bridge between the widget's blueprint and what actually gets drawn on the screen.
Okay, so if the widget is the blueprint and the element is the project manager, what's doing the actual construction?
That's where the rendering layer takes over. It takes the information from the element, including all the properties defined in the widget, and uses it to actually paint the pixels on the screen. So in our case, the rendering layer would draw the rectangular box, color it, add the text, and position it correctly on the screen.
I'm starting to see how these pieces fit together. It's like an assembly line, right? The widget is the design, the element is the worker holding the design, and the rendering layer is the machine that builds the final product.
That's a great way to visualize it. And this whole process happens incredibly fast, which is why Flutter apps are known for their smooth and responsive performance.
This is all really making sense. But now I'm curious about how Flutter handles things that need to change on the screen. Like,
Mhm.
what if we want our task container to turn green when the user marks the task as complete?
That's a great question. And it leads us to one of the most important concepts in Flutter, the distinction between stateless and stateful widgets. So to answer your question about how Flutter handles changes, it all comes down to whether a widget is stateless or stateful. It's like the difference between a printed poster on the wall and a digital display that can change its content. A stateless widget is like that poster. Once it's created, its appearance doesn't change. Stateful widgets, on the other hand, can dynamically update their content and appearance based on user interactions or other events.
Okay, that makes sense. So our task container, which needs to change color when a task is completed, would definitely be a stateful widget. But what's happening under the hood to make that state change possible?
Every stateful widget has this sort of companion, called a state object. You can think of it as the widget's memory. It stores all the information that determines the widget's current appearance and behavior.
So going back to our to-do list example, the state object for the task container would keep track of whether the task is marked as complete or not.
Exactly. And here's where it gets really interesting. When you want to change the state of a widget, you use this special function called setState.
Okay. I've definitely heard about set state. It's like the magic word that makes things happen in Flutter. But how does it actually work? Does it just tell the widget to redraw itself with the new state?
It's a bit more nuanced than that. When you call setState, Flutter does something amazing called reconciliation. It doesn't blindly redraw everything on the screen. It's way smarter than that. It efficiently figures out exactly which parts of the UI need to change and only updates those specific parts.
That's pretty incredible. It sounds like Flutter is doing a lot of heavy lifting behind the scenes to make sure our apps stay performant. But I'm curious, how does it know what to update without going through the entire widget tree every time something changes?
Remember how we talked about elements being like placeholders for widgets? Well, they play a crucial role in this reconciliation process. Each element has a unique identifier, and Flutter uses these identifiers to track which widgets have changed and which haven't. It's like having a super organized filing system, where each widget has its own labeled folder.
So when the state of a widget changes, Flutter can go directly to that widget's folder in the element tree and see what needs to be updated.
You got it. And to make this process even more efficient, Flutter uses a few clever techniques. One is the concept of keys.
Okay, I've seen keys mentioned in Flutter code, but I've never really understood what they're for.
Keys are like unique tags that we can assign to widgets. They help Flutter identify widgets, even if their position in the widget tree changes. For example, imagine you're reordering items in a list. Without keys, Flutter might think you've deleted some items and added new ones, causing unnecessary rebuilding. But if each item has a unique key, Flutter can efficiently track them as they move around.
So keys are like giving each widget a special ID card, so Flutter can recognize them, no matter where they end up in the list.
Exactly. It's a powerful way to optimize performance, especially when dealing with dynamic lists or complex animations.
This whole reconciliation thing is really fascinating. I never realized how much thought and engineering went into making Flutter so efficient. But I have to ask, why should we, as developers, even care about these low-level details? Should we just trust that Flutter is doing its magic behind the scenes?
While it's true that Flutter takes care of a lot of the complexity for us, understanding how the engine works can make us better developers in a few key ways.
Okay, I'm all ears. Tell me how understanding the engine can level up my Flutter game.
For one, it helps us write more performant code. When we know how Flutter renders and updates the UI, we can make choices that optimize our apps for speed and efficiency. We can use keys strategically, avoid unnecessary rebuilds, and structure our code in a way that plays nicely with Flutter's rendering pipeline.
So it's like knowing the rules of the game, right? If you understand how the system works, you can play it to your advantage.
Exactly. It also helps us debug issues more effectively. If we understand how the rendering pipeline works, we can better pinpoint the source of problems when things go wrong. Instead of just seeing an error message, we can understand why that error happened and how to fix it.
That makes a lot of sense. It's like knowing how the engine of your car works. You can troubleshoot problems much more easily if you understand the underlying mechanics.
Precisely. And perhaps most importantly, understanding the Flutter engine can spark our creativity and push us to explore new possibilities. When we know what's possible at a low level, we can push the boundaries of what we can build with Flutter.
I like that. It's like knowing the secret ingredients of a recipe. You can experiment and create something truly unique and delicious. But speaking of exploring, is there a way to actually see this engine in action? To peek under the hood and watch all this reconciliation magic happening?
Absolutely. Flutter provides an amazing tool called the Flutter Inspector. Think of it like an X-ray vision for your app. It lets you visualize the widget tree, inspect individual widgets, and even track performance metrics in real time.
So we can actually see those elements we were talking about and how they're connected to the widgets.
You got it. You can see how the widgets are nested within each other, what properties they have, and even how they change over time as the app runs. You can also see how Flutter is optimizing the rendering process, highlighting which widgets are being rebuilt and which ones are being reused.
That sounds incredibly useful, both for debugging and for just getting a deeper understanding of how Flutter works. I can't wait to fire up the Flutter Inspector and start exploring.
I highly recommend it. It's an invaluable tool for any Flutter developer. It's like having a backstage pass to the Flutter show, allowing you to see all the behind-the-scenes action that makes the magic happen.
This whole deep dive has given me a newfound appreciation for the complexity and ingenuity of the Flutter engine. I'm starting to see why Flutter has become so popular. It's not just about beautiful UIs, it's about performance, efficiency, and a powerful engine that makes it all possible.
It's a testament to the brilliant minds behind Flutter and the incredible community that continues to contribute to its growth and evolution.
Well said. And speaking of evolution, I'm curious about the future of the Flutter engine. What are some of the challenges it faces? And what exciting developments are on the horizon?
That's a great question. One of the biggest challenges for any cross-platform framework is keeping up with the rapid evolution of mobile platforms. Android and iOS are constantly rolling out new features, APIs, and hardware capabilities. Flutter has to keep pace with all of that to ensure that apps built with it can take full advantage of the latest and greatest advancements.
Yeah, that sounds like a pretty intense game of catch-up. I imagine it's a lot more than just making sure the Flutter engine supports the newest APIs. It also has to ensure that Flutter apps continue to perform smoothly across a wide range of devices.
You're absolutely right. It's not just about supporting new features. It's also about maintaining performance and compatibility across a diverse ecosystem of devices. Flutter needs to run flawlessly on everything, from low-end phones with limited resources to high-end tablets with cutting-edge specs.
That sounds like a monumental task for the Flutter team. How do they manage to stay on top of all of that?
One of Flutter's greatest strengths is its vibrant and active community. Developers from all over the world contribute to its development, reporting bugs, suggesting improvements, and even creating packages and plugins to extend Flutter's capabilities. It's truly a collaborative effort, with everyone pitching in to make Flutter better.
That's fantastic. It's inspiring to see a technology with such a passionate and dedicated community behind it. But what about the big picture? What are some of the areas where you think Flutter will evolve in the coming years?
Well, performance optimization is always a top priority. The Flutter team is constantly exploring new ways to make the rendering pipeline even more efficient, reduce memory consumption, and squeeze every ounce of performance out of the engine. We can expect to see continued improvements in how Flutter handles animations, transitions, and complex layouts.
That's great news. I'm always excited to see how Flutter can push the boundaries of performance even further. What else is on the horizon?
Another really exciting area is expanding Flutter's reach beyond mobile. We've already seen the rise of Flutter Web, which allows developers to build web apps using the same Flutter codebase. And there are ongoing efforts to bring Flutter to even more platforms, like desktop operating systems and embedded devices.
So we might see Flutter running on everything from smart refrigerators to self-driving cars. That's an incredible vision. It seems like Flutter is on a trajectory to become a truly universal framework for building beautiful and performant user experiences across any screen imaginable. Exactly. And it's all powered by the flexibility and efficiency of the Flutter engine. The future for Flutter is incredibly bright, and I can't wait to see what developers create with it. This whole deep dive has been a fascinating journey. We've gone from a basic understanding of Flutter to a much deeper appreciation of how the engine works its magic. We've explored the architecture, the rendering pipeline, the state management system, and even taken a glimpse into the future of this remarkable technology.
It's been a pleasure sharing this knowledge with you, and hopefully inspiring you to explore the depths of Flutter and unlock its full potential.
Absolutely. And for all of you listening out there, we encourage you to dive in, experiment, and see what amazing things you could build with Flutter. Who knows? You might be the one to create the next killer app that takes the world by storm.
And if you do, be sure to let us know. We'd love to have you on a future episode of The Deep Dive.
Until then, keep coding, keep learning, and keep diving deep.